Hi class, how are you today? That's fantastic! The learning target for today is to use properties of triangles to solve for missing parts of a triangle. Now, I believe you've seen a lot of this before, so a lot of this might be a review, but we're going to use a lot of algebra in this too. So, if you're a 3, you can solve for missing parts of a triangle. If you're a 2, you can solve for missing parts of a triangle, but only when no variables are involved, so only numbers. You are a 1 if you know the properties of triangles, but cannot solve for missing parts of a triangle. So you know the properties, but can't do anything with them. 0, you don't know the properties of triangles. Remember, please circle at the end of the video, just circle on the scale where you think you are, just so I can see where you think you are. Let's get started. Now we're going to talk about some theorems about triangles. First, the angle sum theorem. The angle sum theorem says the sum of the measures of the angles of a triangle is 180 degrees. So if you have a triangle, WXY, then we can say the measure of angle X plus the measure of angle Y plus the measure of angle W is 180 degrees. And just for a quick notation, M means measure, so it's the measure of angle X, the measure of angle Y. Now the exterior angle theorem. So that says the measure of an interior angle plus the measure of its exterior angle is 180 degrees. So say we have a triangle. So the exterior angle theorem says the measure of an interior angle, so let's say this one right here, plus the measure of an exterior angle, so say this one right here, and I'll mark it with 2 angle marks to show that those two aren't the same. So those 2 angles will add to 180. So we can write it like this. The measure of angle BCA plus the measure of angle BCD is equal to 180 degrees. And remember how we write angles? We say BCA because we want this angle right here. C is the vertex. So we start at B, go to the vertex, and then go inside to A. This one, C is the vertex still, but this time we go out to D, so B, C, D. The last theorem I'm going to talk about today is the vertical angle theorem. The 2 non-adjacent angles created by intersecting lines are congruent. What that means is if you have two lines that intersect each other, the angles that are not adjacent are congruent. Remember, adjacent angles are angles that are right next to each other and share a vertex and a side. So, looking here, this angle right here is adjacent to this angle and this angle, but it's not adjacent to this one. So that means this angle and this angle are congruent. Also, same thing goes with this one over here is adjacent to this one and this one, but not this one. So that means this one is congruent to this one. And notice that this has 1, so the ones with 1 mark are equal. This has 2, so the ones with 2 marks are equal, or congruent. Alright, now let's do some examples with this. So we have a triangle here, and the three angles are x plus 17, x plus 20, and x plus 23. And we need to solve for x. Well, we know if we add those three up, they'll equal 180, right? So, let's say x plus 17 plus x plus 20 plus x plus 23 equals 180. So, combine like terms. So, x plus x plus x is 3x. 17 plus 20 is 37. Plus 23 is 60. So, plus 60 equals 180. And then solve for x. Subtract 60 from both sides. Gives us 3x equals 120. Divide both sides by 3. And x equals 40. Alright, so in this problem, we're given that this exterior angle right here is 129 degrees. This angle right here is 102 degrees, and we need to find this missing measure right here. Well, first thing we want to do is find the interior angle here. So if we have this exterior angle, we know that this interior angle is just 180 degrees minus the exterior angle. So, 180 minus 129 will give us 51. So we know that this angle right here is 51 degrees. With the exterior angle theorem, it says that this interior angle plus this exterior angle will equal 180, but the triangle sum theorem says this angle plus this angle plus this angle will also add up to 180. So from that we can tell this angle plus this angle is the same as this angle right here. So we have that 51 plus 102 is 153 degrees, and that's our missing measure. Alright, one final example. So here we technically have two triangles going on. We have this triangle, which we know has 45 degrees and 15 degrees. We have this triangle as 27 degrees and the question mark that we want to know. And these two are unmarked. So first step, we know two angles here, so let's find the third angle of this triangle. So it's going to be 180 minus these two added up. So that'll give us 180 minus 45 plus 15 is 60. So that's 120 degrees. So this angle right here is 120 degrees. We also know that this line right here is intersecting this line right here, meaning this angle and this angle are vertical angles. And if they're vertical angles, that means these two angles are congruent. So this angle over here is also 120 degrees. So then we can just look and say, this is 27, this is 120, so this must be 180 minus these two. So 180 minus 147, which is 120 plus 127, will give us 33. So our question mark is 33 degrees. Next we're going to talk about properties of equilateral triangles. First property is all sides of a triangle are congruent if and only if all angles are congruent. First thing I want to mention is if you ever see this phrase, if and only if, it means it works both ways. So you can read it as all sides of a triangle are congruent if all angles are congruent. So if all the sides of a triangle are congruent, then that means all the angles of a triangle are congruent. But you can also read it backwards. If all the angles of a triangle are congruent, then all the sides of a triangle are congruent. So if you ever see if and only if, it works both forwards and backwards. It's a phrase that mathematicians use to show that it goes both forwards and backwards. The second property is from each angle, the angle bisector, median, and altitude are the same line. So remember those three lines that I just showed you? In an equilateral triangle, they're all the same line. So if you draw an angle bisector, it also happens to be the median and the altitude. If you draw a median, it's also the angle bisector and the altitude. If you draw an altitude, it's also the angle bisector and the median. Next, we're going to talk about properties of isosceles triangles. First property is two sides of a triangle are congruent if and only if their opposite angles are congruent. Again, here's the if and only if part. So that means it works both forwards and backwards. So two sides of a triangle are congruent if their opposite angles are congruent, or two angles of a triangle are congruent if their opposite sides are congruent. So a quick drawing of that is if these two sides are congruent, remember these little dashes through the sides, mark them as congruent, then that means the angles opposite them are congruent. So we have this angle right here, so the angle opposite it is right here. And then that angle is congruent to the angle opposite this side right here, which is this one over here. So we now know that this angle is congruent to this angle. The second property, very similar to the one from equilateral triangles, is from the vertex angle, the angle bisector, median, and altitude are all the same line. So first, what is the vertex angle? Well, the vertex angle, looking up at this picture up here, is the angle that is not congruent to the others, the one that's in between the two sides that are congruent. So it's this angle right here, and I'll mark it with two arcs to show that it's not congruent to the other two. So that angle right there is the vertex angle. So if I were to draw an angle bisector from that angle, then it would also be a median and altitude, and so on. If I drew a median, it would be the other two, and so on. So very similar to the equilateral properties, but very specific. So the angle bisector, median, and altitude being the same line is only from the vertex angle, not the other two angles. Alright, now let's look at some examples. So in this triangle, we notice that these three angles, since they're marked with arcs, are all congruent to each other. So since they're all congruent, then that means all of the sides are congruent. Remember from the property of equilateral triangles, if all the angles are congruent, then all the sides are congruent. So that means this side is congruent to this side is congruent to this side. So first, let's try to solve for x. So since all these sides are equal to each other, all we have to do is set two of these sides equal to each other, and we can find out what x is. So let's take any two. I'll just take 2x plus 5 and set it equal to x plus 9. And then solve for x. So subtract x from both sides, and that'll give us x plus 5 equals 9, and then subtract 5 from both sides, and that'll give us x equals 4. So we know x is 4. Now we can use that to find the measurements of all the sides. So we know that side AB is x plus 9, side AC is 2x plus 5, and side BC is 3x plus 1. So we can plug in x into all these, and we'll end up getting 4 plus 9, which is 13, and well, if all the sides are equal, we know that all of them will be 13. So we don't have to do anything more than that, and we can just say they're all 13, but just for the fun of it, I'll plug them all in. So 2 times 4 plus 5, so that'll give us 8 plus 5, which is 13, and 3x plus 1, so 3 times 4 plus 1, 3 times 4 is 12, plus 1 is 13. So all the sides are 13. Alright, let's look at another example. So it says here that triangle ABC is an isosceles triangle. So let's start off and draw a triangle. So we've got a triangle, and it's isosceles, so we'll make the marks. These two sides are equal. And B is the vertex angle. So that is the angle that is between the two sides that are equal. And then A and C. So we know that AB is 2x plus 6. BC is 4x minus 2. And AC is 3x plus 10. So the two sides that are equal are 2x plus 6 and 4x minus 2. So let's set them equal to each other. So we have 2x plus 6 equals 4x minus 2. Let's subtract 2x from both sides to get them together. Gives us 6 equals 2x minus 2. Add 2 to both sides will give us 8 equals 2x. Divide both sides by 2, and that'll give us x equals 4. So now that we know x is 4, plug it back into what we had. So 2x, so 2 times 4 is 8, plus 6 is 14. 4 times 4 is 16, minus 2 is 14, which it should be because we originally said that these two are equal, so they should come out to the same thing. If they don't, you probably did something wrong somewhere. And then 3x plus 10, so 3 times 4 is 12, plus 10 is 22. So those are the measurements of all of the sides. Alright, one more example. So in this problem, notice here we have an isosceles triangle here. So the big triangle we see here is isosceles because it has two congruent sides. And we also know that it's got a line going through it that makes it so these two angles are the same. So that means it's an angle bisector. So since it cuts this angle into two equal pieces, it's an angle bisector. And we learned before that if it cuts the vertex angle as an angle bisector, it's also a median and it's also an altitude. So it's also a right angle here. And also these two sides are equal to each other. So if those two sides are equal to each other, because it's a median, that means we can set these two sides equal to each other. So 14 is equal to 3x plus 2. And then subtract 2 from both sides. Gives us 12 equals 3x. Divide both sides by 3. And we have x equals 4. Alright, now for the sponge activity. So, number 1 wants you to find DE with DE, EF, and FD. And you have to solve for x and find DE. Number 2, you have to find QR, knowing that we have RP, PQ, and QR. And again, solve for x to find QR. That's it for the lesson today. Please once again make sure to take notes on the entire lesson. Then complete the sponge to get credit for it. Submit all of it to eBackpack. And have a good night.